Okay, in this question we are asked to find the difference quotient given this following function. So first of all we have to remember the difference quotient, and sometimes it is given and sometimes you will have to remember it. As you advance through mathematics courses you're going to recognize that the difference quotient actually has a higher meaning, and it's actually pretty important that this guy gets memorized. So let's go ahead and write out the difference quotient. The difference quotient is going to be f of x plus h subtracted from your original function all over the value of h. So here in step one, we will ask to find f of x plus h. So everywhere in f we have an x, we're going to plug in x plus h. So here we're going to have 2 times x plus h squared plus a quantity of x plus h minus 4. So in this circumstance, we will have to expand out that x plus h squared, expand out that x plus h squared, and that will give us x plus h times the value of x plus h, which will give us x squared plus 2xh plus h squared. So here, f of x plus h equals to 2 times the quantity of this guy over here, x squared plus 2xh plus h squared. So we'll have x squared plus 2xh plus h, plus h squared, still plus x plus h, still minus 4. Still minus 4. So now we're going to expand out. We're going to distribute the 2, so we're going to have 2x squared plus 4xh plus 2h squared plus x plus h. The plus x plus h comes from this right here. And then we're going to bring down our negative 4 at the end. So this, ladies and gentlemen, will be original f of x plus h, which is this entire value over here. So in this portion of our difference quotient, we have our first part, f of x plus h. So now we can go ahead and subtract the second part. So we're going to have f of x plus h minus original function f of x. So we will have 2x squared plus 4xh plus 2h squared plus x plus h minus 4. So I just copied it directly from what I calculated above. And now we're going to subtract. And when I subtract, I always make sure to put a bracket around my function, make sure I don't forget to distribute that negative. So we're going to subtract our original function, and our original function is 2x squared plus x minus 4. So we're going to have minus 2x squared plus x minus 4. So this value of f of x plus h minus f of x will equal to, I'm going to distribute the negative, I have to rewrite everything else out that I have above. And it's supposed to be a minus 4. It's supposed to be a minus 4. And now I'm going to subtract the 2x squared plus x minus 4. So I have minus 2x squared minus x plus 4, because I subtract here, I distribute here, and I distribute here. So each one of these gets that negative distributed. So notice when we do that, notice the 2x squared cancels with the negative 2x squared, the positive x cancels with the negative x, and the negative 4 cancels with the positive 4. So when you see your original function has been canceled out completely, you know that you're on the right track. That's sort of like your first hint that you know you've done this problem correctly, or you're in the process of doing this problem correctly. So now we can simplify that f of x plus h minus our original function f of x. So we're going to have 4xh plus 2h squared, and then we still have that positive h over here. So we still have this positive h over here. So we have the 4xh, the 2h squared, and this positive h. So now what we have to do is we have to finish off the difference quotient. So we're going to go ahead and we have to recognize that we have to divide by a value of h. So now I'm going to divide this by a value of h, and I'm going to divide this by a value of h as well. Notice in our numerator we have a common factor here. Notice we have an h squared, then an h. So hopefully we can recognize that we can pull out a factor of an h. So we will be left with 4x plus 2h plus a value of 1. So 4x plus 2h plus a value of 1, still all divided by a value of h. So notice now my h's cancel. So I am left with my difference quotient of f of x plus h minus f of x all over h, just to be what's left in the numerator, which will be 4x plus 2h plus a value of 1. So this will be the difference quotient of our function 2x squared plus x minus 4. Moving on to our next question. Notice number 4, this is a graphing question, and it asks us to graph the function f of x equals to the negation of the square root of x plus 3, and we have to describe the transformation from the base function. So let's just go ahead and remember that our base function in this circumstance would be f of x equals to a square root of x. That would be our base function. So I'm going to go ahead and I'm going to do our base function in red. So this will be my x-axis, this will be my vertical y-axis. So here I know that I can draw this out as such, and this will be the square root of x. So this gives me an idea of what this looks like. So now in black, we'll figure out what's going on with this guy. So notice here that we have this value of x plus 3 underneath our radical. So that means that we have had a horizontal shift, and this will be opposite of our sign, so this will be left 3 units. Because remember, we have a horizontal shift if we have f of x plus c, and we're going to have this minus c units. So if this constant is attached to our x, we're going to have a horizontal, this should be horizontal shift, negative c units. So that's why we're going to go back 3 units. So we're going to have to start off 1, 2, 3. So we know we're going to start off back there at 3. And then we realize that we have the negation of our function. So here f of x is equal to the negation of f of x. So if we negate our function f of x, that means that we are going to revolve f of x about the x-axis. If you negate value of y, in essence f of x is equal to value of y, you revolve about the x-axis. If we were to negate just our variable x, we would revolve f of x about the y-axis. So if we were just to negate x, we would revolve around the y-axis. So in this circumstance, we're going to revolve about the x-axis. We have to revolve around the x-axis because we have just negated our entire function. This negative is negating the entire function. So if we revolve around the x-axis, we're going to be revolving around this axis right here. So that means that we are going to go opening now down, and we're going to go over like such. So this will be the negative square root of x plus 3. And how can we test this, ladies and gentlemen? Again, we could just plug in values. So based off of what we hypothesize, we expect at negative 1, 2, 3 that we should have a value of, this value should be negative 3, 0. Negative 3, 0. So let's see what happens when we plug in f of negative 3. That will equal to the negation of negative 3 plus 3, which will equal to the negation of the square root of 0, which is equal to just a value of 0. And notice that checks here. So that means that's a good check. We also know that at 0, this function should exist. It should exist somewhere down here. So let's go ahead and find f of 0. Finding f of 0, we're going to have negative square root of 0 plus 3. This just gives us negative square root of 3. And we see here that we fall somewhere down. It doesn't have to be perfect. This has to be a generalized graph that we're going to be down negative square root of 3 units. Negative square root of 3 units. What did I just do there? So let's pick a value that we know doesn't exist. Let's look over here in blue. Let's see if we go 1, 2, 3, 4, 5. Let's go 5. So here at negative 5, we don't expect our value to exist because our graph only exists from negative 3 on to positive infinity. Our domain of this function will start at negative 3 and continue all the way on to positive infinity. So let's go ahead and find f of negative 5. When I plug in negative 5 for x, I get negative square root of negative 2. And we realize this guy does not exist. He is imaginary. And therefore that makes sense because we don't expect this value to exist at -5. We hypothesize that our graph is only going to start at -3 and continue on to positive infinity. So this gives us a base idea of a function transformation. If you have to review, and you don't recognize some of this, go ahead and review functions and transformations. So if this was not familiar to you, go ahead and review transformations and functional transformations. That will help bring back some of the memories that maybe you haven't seen in a while.